All right. So this is the first one we had questions on. This was number 1 from the trig one. Okay. So the first thing to find the derivative, we're separated with addition and subtraction, which means I can do the derivative of one and then subtract the derivative of the other. So the derivative of cosine is negative sine x. The derivative, derivative of tangent is secant squared, and we have a constant multiplied in front. So this is the derivative. And then f prime of 4 just says, now put 4 into the derivative now that you know what it is. So negative sine 4 minus 2 secant squared of 4. You might be able to enter it even just like that. If you were on a regular calculator, you want to make sure that you were in radian mode. Calculus doesn't like degrees. Okay, so you want to make sure that that the calculator is in radian mode when you come up with a number for this. If I was putting this into my old scientific calculator that I bought at Radio Shack in 1986, and it's still in my drawer, I would do this as this, and then square that to come up with that approximate answer. Okay. Any questions on that one? Or does that make sense? Or whoever asked it, do they hopefully now see what's going on? Okay, let's see. For this one, let that go away. Find the equation of the tangent line to the curve. Y equals secant x minus 10 cosine x at the point pi over 3 comma 5. It was nice of them to give the y coordinate to us. It says the equation of that tangent line can be written as y equals mx plus b, and they want to know what the slope is and what the y-intercept is. So to find the slope, we've got to come up with we already know so far to start out, we're going to have y minus 5 is equal to something times x minus pi over 3. Okay, we're sitting on that part so far. We just need the slope. Slope comes from the derivative. Derivative of secant is secant x tangent x. So we got 5 secant x tangent x minus, which is going to become a plus 10 sine x. We're going to do that. And we're going to evaluate that at x equals pi over 3. So we'll have to remember some things. Pi over 3 is a 60-degree angle. All right. So in our 30, 60, 90 triangle, when if this is 1, that's 2, that's the square root of 3. All right, so we should be able to build all these values off of that. The secant, well, the cosine is a half, so the secant would be 2 times the tangent, which is the square root of 3, plus 10 times the sine, which is the square root of 3 over 2. So I've got a 10 root 3 plus a 5 root 3. Sounds like a slope of 15 root 3. So my slope would go in here as 15 root 3, and that's my slope. 15 square root 3. If you click in the box, it should give you the stuff you can pull up, or if you just use SQRT, that makes the square root symbol. The b is going to be a little messier because it's going to be negative 15 root 3 times pi over 3 plus 5. We could simplify a little bit here and make this a negative 5 root 3 times pi plus 5. So maybe write it as a 5 minus 5 pi root 3. Okay. And you can put expressions like that into the boxes in WAMAP, and it will evaluate that and check that it is the number that you're looking for. So even in previous less simplified versions of that, it should still take the answer. Okay, this one just straight up asking for a derivative. So derivative of cosine is negative sine. The derivative of tangent is secant squared. Now, WAMAP, I don't recall if it will take, I think it will take it just looking like that. So you can actually do that if you're trying to do secant squared on a graphing calculator. You can't put the squared on top of the secant like that. And this is a kind of a shortcut notation that that we can use when we're writing things out. But I know the Texas Instruments graphing calculator, for one, most of them don't have a secant button. And for two, you can't square a trig function that way. It doesn't recognize what you're talking about. And did we have one more? Okay. Find the 71st derivative of the function, obviously 71st derivative of the function f of x equals cosine x. So through repeated derivatives here, I'm not able to apparently make that, there it goes. Okay. Well, let's see what, let's keep track of the derivative number. So the first derivative of cosine is going to be negative sine. The second derivative is the derivative of that. So the derivative of sine is cosine. We have a negative in front, so this is going to be a negative cosine. The third derivative is going to be sine, because the derivative of cosine is negative sine, and this says change the sign on the negative cosine, on the negative sign. Okay. And the fourth derivative would just be cosine, and the fifth derivative would be negative sine, and the sixth derivative would be negative cosine x, and I see myself in a pattern now, right? So every four, it just repeats. So I don't have to make my list all the way to 71. I could probably figure out that 71 is one short. If I divide 71 by 4, I get a remainder of 3. So that might be indicating I do a little bit more checking, but I think that's probably pointing about that direction. So of the things that have a first derivative, if I divide that by 3, I get a remainder of 1. Second derivative would be a remainder of 2 when I divide by 4. So breaking these into groups of 4, I feel pretty good about that part. All right, here we go. Quotient rule, remember, is bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. Yeah, man. So we start out with the bottom, which is the 9x to the 10th minus 3. Careful with the parentheses. All of that times the derivative of the top. I'll do top stuff in a different color, okay, because I can. The derivative of negative sine x minus 10. Derivative of sine is cosine. It's got a negative 6 in front of it. So, and the minus 10 is going to go away because it's just a constant. Okay. So there is bottom times derivative of the top, okay, minus the top, which is the negative 6 sine x minus 10, times the derivative of the bottom, which is going to be 90x to the 9th. And that's going to be all over the bottom, 9x to the 10th minus 3 squared. And it did point out that you don't necessarily need to do any simplifying on this. I would probably, just to keep things clearer here, this negative could go inside here and make those both positive, and then everything would be addition there. So I definitely use the tools in there to start by creating a fraction and then put all of this stuff up here as it appears in the parentheses on the numerator part of that fraction, then go down and put it exactly as it appears in the denominator of the fraction. So specifically said you don't have to worry about simplifying things along the way there.